So sometimes if you see these equations, it's not first order linear equations, which means the coefficient of the y prime or y part or qx part is not only as function of x or constant, then can be reduced such nonlinear first order ODEs to be linear. Okay, so and solve using the linear form solutions like what we present previously. Then let's see classic examples which can reduce the nonlinear ODE to be linear. That example is called Bernoulli equations. So reduction to linear form, which is a Bernoulli equation as an examples. Okay, so some non-linear equation can be reduced to linear form while substitution. And this example is the Bernoulli equations. And what is the Bernoulli equations? You can see that is y prime plus py equals qy to the a's power. And if we know that the y prime and py, that is the coefficient is constant or as function of x only, and this q is as function of x only, but there is a y to the a's power part. So clearly this is not a linear equations, ODEs. Then how we can make such nonlinear form to be linear? Okay, a note to know that if my a equals to 0, that is a linear form. So it's qy, that is a linear form. There are some conditions, it's linear ODE. If my a is equals to 1, then you basically can doing the separable form. So that is the equation become y prime that is equals to q minus p y, right? If a equals to 1, then you can do that dy over q minus py equals dx. So this is a separable form, right? Then if a is now equals to 1 or 0, then that is the nonlinear part, okay? If my a is now equals to 0 or n, a is now equals to 1, to linear such system, we use a substitution. What is this substitution? Is u equals y to the 1 minus a part, okay? And then what we can do is the du over dx will be equals to the dy to the 1 over a 1 minus a over dx, and that is equals to 1 minus a y to the minus a dy over dx. Okay. And what is dy over dx? What is dy over dx? Dy over dx is y prime, which is qy to the a minus py. So it's 1 minus a y to the minus a power qy to the a minus py. Okay. And then if we put this y to the minus a power into the equations, this qy to the a minus py, that will be equals to 1 minus a q minus p y to the 1 minus a's power. Okay? And what is the y, py, what is the y to the power of 1 minus a? That is our substitution u part, right? So what we can write is 1 minus a times q minus pu. Okay. And you can see that the left hand side is du over dx. The right hand side is 1 minus a times q minus pu. So we can rewrite these equations to be a linear equations using the u function and the x. Then that is u prime plus 1 minus a pu, that is equals to 1 minus a q. And you can see that the coefficients of different term is constant or as function of x only, so that we change the previous, the non-linear first order ODE to be a linear ODE. First order linear ODE for UX.